Hello, everyone. So today we are going to continue on with our solving these different linear systems. Okay, where we're given two different linear equations, and we're trying to figure out, okay, what is the point where they intersect? What is the point that solves both of these different equations? So yesterday we had talked about, okay, how do we do that by looking at the graph and graphically. I would say for most people that's probably not the simplest way to do it. A lot of people prefer to solve these out algebraically. Okay, I know a lot of people graphing is not their most favorite thing. So we're going to go into how are we able to do this without looking at the graphs, just by using algebra. So there's one method that we call substitution that we're going to do first. We're going to cover that today. On Monday, we're going to go a little bit more into it. And then we're going to take a quiz coming up pretty soon. Then we'll get into another method that we call elimination. And that's going to be just a slightly different way of solving it. But substitution, it's kind of what it sounds like. Okay? You're substituting part of an equation into another equation. I'll show you what I mean. Let's look over here at A. I've got two equations. I've got y is equal to negative 2x minus 9, and then I have 6x minus 5y is equal to negative 19. So I have to look and see, okay, which one of these equations is the best setup for substitution? And it's this one, because I have y is equal to something. Anytime you have y is equal to whatever, or x is equal to whatever, when you have one variable that's on its own, that is going to be the one that's really set up easily for substitution. We'll go into, we talk a little bit more about this on Monday. We'll go into how to solve these out when it's not quite set up that easily and you have to do a little bit of algebra, but all the ones for today are set up just like this. Y is equal to a number, x is equal to a number. So you want to say, okay, I know that y is equal to something, and it's equal to negative 2x minus 9. Okay, that's my first equation. Y is equal to negative 2x minus 9. So then I'm going to take my other equation, okay, this 6x minus 5y is equal to negative 19. And I'm going to say I can't solve this out when I've got two different variables here. I have to have all the same variable in order to solve this out. So what can I do? Well, I know that y is equal to negative 2x minus 9. So instead of y here, I'm going to replace that with negative 2x minus 9. So let's write that out. I've got 6x minus 5. Instead of y, I've got negative 2x minus 9. Whenever you're plugging something like this in, you want to use parentheses. Okay, it's 5 times y. It's 5 times negative 2x minus 9. Okay, so always use parentheses with this. Otherwise, you might end up mixing yourself up a little bit. Okay, minus 5. We plug this in for y is equal to negative 19. All right, so let's go back to this algebra. I know it's been a while since we've solved something like this. We've been doing a lot of graphing and other type of things for a while. So, okay, now this is just an equation, so I can solve this out. I know there's parentheses in here, so the first thing that I'm going to want to do is to use my distributive property. So that negative 5 is going to get distributed to the negative 2x and to the negative 9. Okay, so 6x. Okay, negative 5. Remember, it's negative 5, not positive 5. So negative 5 times negative 2x is positive 10x. And negative 5 times negative 9 is positive 45. Right? And then is still equal to negative 19. Then is, oh, I didn't mean to move that. Okay. Oh no, can I move it back? Here we go. Oh, right. Anyways, didn't mean to do that. All right, so we are now thinking, okay, what's the next step I can do? I can combine my like terms. Okay, so let's see what my like terms are. I have a 6x and I have a positive 10x. So those can get combined. I'm adding those coefficients. So I've got 16x plus 45 is equal to negative 19. I want to get rid of this 45 first, so I'm going to subtract 45 from each side. All right, so I have 16x is equal to, trying to do mental math, negative 64. And think about it for a second, make sure I didn't do something goofy. Yep, negative 64. And then last step, 16 times x. Well, I want to undo that, and I'm going to divide by 16. So divide each side here by 16, and I'm left with x is equal to negative 4. Negative divided by positive, I get negative 4. Biggest mistake people make is they go, whoa, that was a lot of math, I'm done. Okay, x equals negative 4, because they're used to that being the answer. But we're not quite there yet, so actually let me not box this up, because I don't want you to think that's the final answer. That's like halfway to the answer. Let me underline it, okay? Because just like we were doing yesterday when it was an ordered pair, it still needs to be an ordered pair. So we need an x and a y value. Okay, the good news is it's usually a little bit easier to find the y value. So over here, let's say, okay, I've got this x equals negative 4. You're allowed to plug that x into either one of these equations and then solve for y. I would say usually if you already have this equation where one variable is isolated, I would say this is usually the easier one to solve for. So I'm going to plug this negative 4 into this equation to solve for y. So y is equal to negative 2 times negative 4, that's getting plugged in for x, minus 9. All right, so y is equal to negative 2 times negative 4, that's positive 8 minus 9, which gets me negative 1. So there's the second half of my answer. All right, I have negative 4 and I have positive 1. So I'm going to put that in an ordered pair. Okay, so x is always first, so negative 4, negative 1. That's my final answer here. Okay, negative 4, negative 1. Okay, now don't get too discouraged. I know that's kind of a lot of work for one problem. All right, I'm going to go through some of these other examples with you. It's pretty much the same process for each one of these, at least for today. Okay, you identify, so let's look over here at B. You identify which of these equations is set up for substitution. So I have 4x plus y is equal to negative 3. And then I have x is equal to 6y minus 7. Well, x is equal to 6y minus 7. I have variable equal to something. I don't have to rearrange anything. It's already set up the way I need it to be. Variable equal to something. So I know I'm going to take this little chunk here, this 6y minus 7, and I'm going to replace this x so I can solve for y. Okay, I'm going to take this 4x plus y is equal to negative 3, and I'm going to say, okay, now instead of this x, I know x is the same thing as 6y minus 7, so I'm going to replace it. I'm going to say 4 times 6y minus 7 plus y is equal to negative 3. Same thing. I've got parentheses, so I know my first step is to distribute. So I have 24y minus 28. Sorry, I was distracted. I was distracted by my husband. I promise I know what 7 times 4 is. All right, plus y is equal to negative 3. All right, so 24y minus 28 plus y is equal to negative 3. Okay, I can see right here I've got two y terms. I know I'm going to have to combine my like terms. Okay, remember, if I don't have a coefficient here for just y, it's 1. So 24 plus 1, I get 25y minus 28 is equal to -3. Okay, so I don't want this -28. I want to add 28 to both sides here. Okay, so I have 25y is equal to positive 25. So divide each side here. I have multiplying by 25, so I'm going to divide by 25. And I get y is equal to 1. Okay, again, don't get tricked and say, oh, y is equal to 1. That's my answer. You're halfway to your answer. Okay, we still have to take that 1 and plug it back into one of your original equations. It doesn't matter which equation. You should come up with the same answer either way. So I usually think that the original one is the easier one, at least when it's set up like this. So x is equal to 6y, so 6 times 1 minus 7. Well, 6 times 1 is 6. Minus 7, I get -1. All right, so my ordered pair here is -1, positive 1. All right, take a second and see if you can pause the video and come up with your answer for C. I'm not going to walk through this entire one like I normally do, but pause for a second, see what you come up with. I'm going to do the problem as well, and let's see if we come up with the same answer. All right, so hopefully we ended up with the same answer here. We have another assignment just similar to the other ones. You either maybe picked up that packet or you can just find that PDF there on today's folder. You can go ahead and get started on that. And I will see you guys tomorrow.